Hey everyone, great to see
Hi.
everyone's faces. Hi. First off, I want to thank you all for taking the time and thank all the listeners for joining us today. I'm really excited. We'll be discussing the topic everyone loves more than anything, which is infrastructure. And so we're going to dive a little bit into smart contracts and nodes specifically. But first, I want to give a huge thank you to Draper Goren Holm for hosting the Global DeFi Summit and for bringing all these incredible speakers together. So why don't we start off with a brief introduction? Medha, maybe starting off with you, and we can go around before diving in.
Sounds great. I'm really excited to be here, and thanks again to Draper Goren Holm for having us on. I'm the CTO and one of the co-founders of CasperLabs, and we're building a new layer 1 protocol that supports the governance of on-chain code, right? Both for businesses as well as for DeFi protocols. It's something we believe is one of the primary barriers to adoption, along with scaling. Our protocol is scalable, secure, and supports Turing-complete smart contracts. Very happy to be here.
Perfect, thank you. Austin, you want to go next?
Yeah, I'm Austin Roberts. I am the technical co-founder and CEO of Open Relay. Our primary products are Open Relay, which is 0x order book infrastructure, and Rivet, which is Ethereum node infrastructure. And we're happy to be here and happy to be talking to you.
Great. Awa, you want to go next?
Hear me? I kind of lagged for a second.
Oh, I think we may have you on mute.
Well, we can hear you now. No,
you can hear me?
You're good.
Perfect.
Yeah, we can hear you.
Yeah.
Okay, thanks. So CryptoLabs is a proof-of-stake validator who offers staking services to the public and is based in Switzerland. Another characteristic of a validator is that our setup is as decorrelated from the rest as possible, meaning that we operate as much physical infrastructure as possible, or rely on HSMs as much as possible. And then the other characteristic is that we don't just contribute to security of networks, but also participate actively as technical governance stewards for networks who actually have on-chain governance, as well as in other forms in some networks. Maybe I'll speak about it a bit later. We contribute to the community development and then in providing open source tools for other validators.
Great. Cool. Well, so excited to have you all on the line. I want to take maybe a step back because I know I'm not sure exactly who's listening on the audience, but want to really quickly define what we're going to be diving into today. So some time to describe what are smart contracts and how are they important to DeFi infrastructure as a whole and relative to what you're currently working on, and the same for nodes. So maybe on the node side, Austin, you want to kick us off with how it relates as well to what you're working on with Rivet?
Yeah, sure. So when you're talking about blockchain technology and DeFi, when you're interacting with a blockchain, you need to get the information about what's going on that blockchain from somewhere. So what you use for that is a blockchain node, and if it's Ethereum, you're talking about an Ethereum node. I'm sure Medha will talk briefly about the CasperLabs nodes. But smart contracts are essentially the code that runs on the blockchain, whereas the nodes are the servers or software that you use to interact with the blockchain and get that information.
Perfect. And I know you're working on something which you mentioned earlier called Rivet. Can you kind of explain to us?
So Rivet is
specifically?
Ethereum node infrastructure. So we kind of took a step back from, Ethereum nodes can be especially hard to manage. You've got hundreds of gigabytes of data. If your node goes down and you've got to recover, it can take hours to recover from a backup, or days if you have to recover from scratch. So at Rivet, we put together an open source project to help make Ethereum node infrastructure much more operationally manageable. The scale of that ended up being a bit heavier than we wanted, but we decided that rather than scrap the project, we would offer it as a hosted node infrastructure project. So at Rivet, we You can sign up for Ethereum node data, and we run the nodes. So all developers who need that information have to do is drop our API key into their application, and they're off and running.
Great. And I know we spoke about it. We touched on it on the last panel as well, how important it is to get that constant data flow. Medha, I know something you're working on specifically is Casper, which is a little separate from the Ethereum nodes. Can you kind of describe what the idea is there, and also the importance of node infrastructure?
Yeah, absolutely. So Casper, we're building, a new blockchain based on the Casper protocol, the CBC Casper protocol. We finished off the work that was bootstrapped in 2017 from Ethereum Research, and we completed both the formal mathematic proofs, and now we're building a blockchain to actually see that this protocol works correctly. And so what's really important around, node infrastructure, in my humble opinion, is you need to be able to monitor your nodes. You need to be able to manage your nodes. It should be very easy to spin up. There's a lot of the same properties you see in traditional software as a service, SaaS software. The backbone that powers Visa, the backbone that powers Amazon, those production grade servers, you need that kind of production grade server infrastructure in your nodes, right? And so the software that we're building, the node software that we're building that's going to power the blockchain is going to come with all of those hooks, right? You need to be able to do all the things that what they call your site reliability team needs in order to be able to effectively monitor and manage your servers, right? And this is all about uptime. Validators that are going to be running nodes, they're going to care about that server being up and to be able to tell them when there's a real problem.
Perfect. Yeah. And I think you touched on some really important topics. We tend in the industry to talk about adoption a lot, but I think we don't dive into the importance of infrastructure, uptime, being able to scale that significantly, Austin, to your point, with more and more transactions. So Awa, I'd love to hear your thoughts both on smart contracts and nodes, and maybe define how important it is to what you're currently working on with scaling the infrastructure.
I would like to first make a distinction for the audience, maybe. So what Austin spoke mostly about are nodes that provide data. So technically speaking, like for example, archival nodes, full nodes, or other layers that provide APIs, public APIs, tooling, and then other ecosystem applications, let's say wallets, etc. But what Medha was speaking about, and then what CryptoLabs operates, is actually consensus nodes. So our job is really to, as she mentioned, to provide them, ensure that the backbone on which smart contracts programs on a decentralized virtual machine actually are secure. So first of all, that everything runs safely, but also with enough reliability, so available, and so on. How this relates to the work we do at Cryptium. So CryptoLabs is in charge of actually making securing these networks. And on the other hand, in the case we're actually running a proof of stake network that has a virtual machine, like for example, Tezos, or any of the new ones that are coming out, or Ethereum. In that case, we're also executing smart contracts, and then checking also that the programs are running and not doing double spending, et cetera, et cetera. But I think it extends a little bit beyond the role, but maybe you want to talk about this a bit later, like the role of validators and so on.
Perfect. No, that's super helpful. So one of the topics I wanted to take some time to discuss is some of the things that are holding back the industry with regards to the infrastructure, and things that I think both projects and people in the industry need to be mindful of. Those can include on the security side, which I know is a really big word, but when you break it down, what are some of the security risks that you guys are looking for and building against to help some of these projects scale, whether it's on the governance side, which is also a really important topic, and as well on just the importance of layer one protocol. These are all kind of building blocks that are included in the infrastructure layer. But to get to that adoption, things that, different projects and folks in the audience should keep in mind when looking at either building it internally or using other services. Who wants to take that
I'll
first?
take it first. Yeah. So, CasperLabs, we really care a lot about security, right? We're building a decentralized, permissionless, pure proof of stake protocol. And one of the things that we're really focused on is that our research is grounded in mathematics, right? So the protocol is both provably live and safe. It is not statistically safe. It is not probabilistically safe. It is provably live and safe. So that's the first thing that's super important. Second thing is being decentralized and permissionless means you have open access for anybody to come and go from the protocol as they wish. This is a cornerstone of proof of work and really where a lot of the security from Ethereum and Bitcoin comes from, right? And that's why you see so much value locked up in those two protocols, is because people know, it's very clear that anyone can run. It's not easy, but it is possible. The third thing is in the Casper protocol, all of the stake that is staked in the network participates in validating and securing transactions. And this goes back again to probabilistic or statistical security. If you have $10 million of stake bonded to the network, it doesn't matter how big or small your transaction is. You really want every single validator validating your transaction and putting that stake in securing your transaction, right? These are a few of the important properties that we're really focused on. And then finally, with governance, as you hinted, governance, we believe, needs to happen on chain as much as possible. And for these DeFi protocols, decentralized governance is especially challenging. And you really want to be able to leverage the blockchain to govern your DeFi protocols on chain. And we have really strong set of tools that we've built in the protocol to support that.
Perfect. That's really, really helpful. Austin, curious to get your thoughts on those three, or anything else that's really top of mind when building.
Yeah. So, at Open Relay and at Rivet, we've really taken things down a layer to how things are actually running at an infrastructure layer. So, it's one thing to talk about the math behind the security, that level of security that you have. It's another thing to talk about the hardware. So, a lot of the projects that are building on DeFi today are, out there assuming that the infrastructure underlying their systems is just going to work. And, they don't want to spend their time thinking about, infrastructure. And, even to a degree, they don't want to think about the protocols either. They want to assume that, this protocol is going to work as advertised. And not necessarily think about, what are the edge conditions of this protocol. So, at Rivet, one of our key things has been, we've been building infrastructure that just works and just scales. But when we started Open Relay, we started it thinking, okay, Ethereum infrastructure, that's a solved problem. We're going to go build this order book infrastructure. And as we built the order book infrastructure, we really found that the least reliable part of our stack, and the thing that we had to spend the most time on, was our node infrastructure and just, keeping the servers up and making sure that we could actually maintain those things. And so, that's the level that we focus on. The protocol layers are spectacular. And, our goal is really to provide infrastructure that those protocol layers can build on without having to worry that the infrastructure layer is not going to be there unexpectedly.
Yeah, that's a really great point. So where would you say node infrastructure is today, and what's holding it back from where it needs to go to be really at that point, like you said, where people can start focusing on layer one and the protocol layer alone?
Well, and what we've done at Rivet is really build enterprise grade Ethereum software that when you go and you download Geth or you download Open Ethereum, those are the conventional Ethereum node infrastructure. Those are designed to run on a desktop. They are designed for one person to run an instance that they can get the information that they need from it. They're not designed from the ground up with the idea, like an enterprise database where you expect that this is going to be running in a highly available cluster. There's no way to run those in a highly available cluster, or there wasn't until we came along with our fork of Geth. And Medha's talked about how at CasperLabs, they have really taken a lot of those things to heart as they've built out their tooling, and that's great. But really, I think there's still elements of the ecosystem that need to be focused on, how do we build these things for enterprise grade, and how does that look different from building them from what somebody's going to be running on their laptop at home?
Mm-hmm.
I actually have something to add to this topic.
Fair.
Go for it.
Yeah. So actually what you said, Austin, is so true. A lot of times when we see a network that has been even going through after a lot of testnet versions and then eventually launching, a lot of times what we see as validators is that we run it and then there's a lot of problems with it. And the part of the reason is because a lot of these protocols are really complex. So in the case of Casper, you are literally launching a novel consensus algorithm with this, which means that you also had to think of the grid economics behind it. And I think it's really valuable that you have firmware verified the algorithm. But a lot of times you will find out that in practice, you don't really test actually the reliability of this or the tooling or also the software you have released until random validators out there in the world in a synchronous fashion start running and operating it, right? That's where we really test the system and so on. And I think
that's super important.
But I think also that a way of a bottleneck that we're running with, we are especially experiencing with all these new protocols launching, we only validate protocols that are technically novel. So we face the problem every single time until a proof of stake model has been standardized. This is the one that works and everyone does the same, but we're not there yet. So I think that a way of removing this bottleneck will be to get the validators to actually be more involved in testing, really stress testing these protocols, because a lot of times validators just download the software. A lot of times it's just a Docker image and they just run it and say, okay, this is fine on cloud and everything. But actually validators are in the best position to go for white hat approaches or even dive deep into the code and see, for example, is there any exploit? And exploits could be anything from inflationary bugs, it could be just about security, something like a mismatch between the design of the protocol or the implementation, it could be anything really. But there are very few validators that are incentivized to do so.
Yeah, I completely agree. Absolutely. One of the things that we did build at CasperLabs is we've actually built a test infrastructure that goes along with the system. So you can actually, it's in software as a service, when you getting ready to ship a new version of software, for those that don't know it, you have your production, readiness team, and they basically take either your production load or some flavor of that, and they point it at that server to see how hard and robust it is, right? So we went ahead and built that infrastructure internally just to test uptime and robustness and performance, right? And it's our intention to turn this infrastructure over to the validators, put it in their hands, right? And run those tests in testnet to make sure that their infrastructure is robust and solid, right? It's to really build a protocol like this, you need to focus on all layers of the stack. You got to start at the very bottom, which is the server infrastructure, and even the wire underneath that. But then you will need to go all the way through the stack to usability for the end user. It's non-trivial.
Mm-hmm. Yeah, absolutely. So I'm curious. I know we spoke specifically to kind of one project, but what about cross-platform? I think that kind of opens up to a whole new frame of different issues, whether it is security. I know that's something, Medha, you mentioned. The other is just different protocols supporting and different smart contracts interacting with each other on different protocols. Awa, I know that's something that you had mentioned. Maybe want to touch on how, when you're starting to look at the way different protocols are interacting with one another, what are some of the issues that we currently have today that you at least think about on a day-to-day basis?
Interoperability. So to me, in order to make real DeFi accessible for everyone, and by DeFi, I know the term is really broad, but on one hand, I think it's the utility aspect of it, the fact that I can kiss my bank goodbye and then receive salaries and so on, pay things on my day-to-day basis with this kind of platform instead of using traditional banking systems. And on the other hand is making, for example, investments more accessible, et cetera, for everyone. I think one major problem, which very few people really in the entire blockchain space is looking into, is how to make all these different protocols that I think is unlikely that in the future there will be only one protocol. I think that it was most likely is that in the future is going to be different platforms that are specialized with different use cases. But the problem is that at the moment, the assets that are issued in one platform cannot really live in another platform. It cannot really be transferred or traded in other platforms. This is what I mean by interoperability across chains. And the reason why that doesn't work yet is because we're still building protocols as like, this is my protocol, this is my community, this is my ecosystem of applications. And not that many people are actually looking into standards that allow them to like communicate and pass packages across different blockchains, no matter how different architectures is. There is one initiative, is the IBC protocol, which is one of my co-founders is actually one of the lead developers in there, the IBC protocol. And then in the aspect of smart contracts is also another thing. So at the moment, with virtual machines with Ethereum, Solana, all the other platforms, they have their virtual machine and they have their stack of tools that only compiles onto this Debian bytecode or to this virtual machine lower code and so on, right? Which means that if I'm a smart contract developer, I have to choose a platform and then I have to like write the smart contract, which only works in this platform, by the way. And it might not only work properly in this platform because of the, for example, in Ethereum, smart contracts are composable, but it's like it's really scary to deploy a smart contract in Ethereum because even if you have properly audited, formally verified, or whatever your smart contract, if it interacts with others, how can you make sure that the composability of the smart contract is safe? And that is only on Ethereum, and I think that is the one challenge that even today we don't really have all the tools necessary for people to write and deploy really safe smart contracts. And then, of course, at the moment, those smart contracts only live like in one platform, which I guess it's fine. I guess if you can just like, as a developer, you can learn another language and then write it again. But to that vein, there are some initiatives that are platform agnostic. And then actually one of them is Metastate is the other team I co-founded, and it's an R&D company. And we're working on a platform language called Jivix, which allows you to write smart contracts that later on has different compile targets and so on. So these are different approaches that you can, that could help really incentivize a little bit more interoperability of not only, in the case of IBC, so the tokens to be transferred securely or even privately in this case to other platforms. And in the case of smart contracts, then the tooling that allows you to write one smart contract for all. And then also that it has some properties like composability of proofs, etc., at the high level language.
Mm-hmm. Great. And Medha, curious to get your thoughts both on that, but also on the liquidity pool, kind of a cross between different What are your thoughts there? And I know one thing that you really focus on too is.
Oh, I don't know if it's my connection or yours, but you broke up there a little bit. Can you hear me?
Yeah, I didn't hear the end of that either.
Yeah.
Yeah, I think is that Aya's.
Aya, could you? Yeah, I think she's having a connectivity issue. I'm going to try to answer her question. I think she's asking about liquidity pools and interoperability between them. So I think we're not there yet. I really feel like
on those two as well in terms.
Yeah, I think.
Oh, sorry, guys. I think you lost me.
Yeah, I think we lost you.
I was. I'm back. Sorry, this hurricane definitely hit this area hard. So sorry about that. But wanted to get your thoughts, Medha, on one thing that you specifically focus on that I think is really interesting is both on the liquidity pool side and the transactions side. So cross-platform, what are some of the things that need to scale that we need to think about as it relates to DeFi there?
Yeah, I mean, so I don't think we're there yet to actually have blockchain interoperability really nailed down, buttoned down yet, right? This is like an EDI kind of problem that you see. It took a long time to come up with electronic data interchange format. You see the same problem even with electronic medical records. There needs to be some standards around, data interchange, right? And I think Coinbase recently coming out with Rosetta and trying to push everybody in the blockchain space into a single standard. This is good. These are good things, right? And from our perspective, we're trying to build a protocol that's very, very flexible, that gives contract authors access to the data and proofs that they need. So, as long as the protocol is really flexible and gives you what you need, we're hoping that we're banking on it being able to evolve, to stand the test of time, so to speak. So from my perspective, I don't believe the security guarantees are there yet to do pure blockchain interoperability. I do think that there's a great place to do that, at the contract level, right? So you can basically, there's DEXs and there's a lot of great work that's being done there to enable a secure way to exchange assets from one blockchain to the other. But I don't think we're there yet for like native blockchain interoperability, if that's what you're asking me. I just don't think the security, requirements have been met yet.
And I would add that
once
we are, you're still going to have some interesting issues with liquidity pools. So, just because you can represent a token from one blockchain on another blockchain and be able to trade them on the blockchain, you still end up with some significant liquidity issues in that, if most of the assets for this blockchain exist over here and you're trying to trade it over here, the liquidity on this side is going to be such that, you're probably going to see a lot of slippage because that's not where the liquidity for that asset exists. I suspect in the long term, we will see some interesting solutions to those problems, but I have no idea what they're going to look like.
Yeah. We're still a ways away from that, I think.
Also a major challenge
That's a great point. So I know we're short on time, but I want to end this on an optimistic note because I know we just spent at least 15 minutes talking about what we need to work on. But Medha, you spoke about Rosetta with Coinbase. I agree. That's definitely a step in the right direction in standardization. What would you say is something that, at least in the last 6 months, the space has done really, really well in terms of making strides in infrastructure?
Wow. I'm really excited about all the layer 1 protocols that are coming out. I think there's still a great deal of innovation that's happening. I would like to see more focus on security and less focus on transactions per second. I just feel like, a full VM state transition is not the same as buying a cup of coffee, and it's really apples and oranges, right? So I think we've made some good progress in terms of really kind of focusing on the security of the consensus protocols and platforms that are being released. And I love to see the innovation. I'd like to see us continue to move forward, stepping away from the TPS number, because I think it's just a hollow number that doesn't really represent anything, to be honest.
Waiting for the comment section on I'm curious to get your thoughts as well. Something you're optimistic about in the last 6 months.
I'm actually really excited to see novel consensus algorithms come to be actually to be tested in live production systems. And I'm also excited to see how proof of stake actually plays out. So proof of stake actually hasn't been in production for that long. And even today, we still see protocols that launch with a slightly different variation of it. Which means the security assumptions and everything around it is different. And also, we haven't really seen like an actual adversary attacking these networks yet. And it might be that so until that happens, that somebody, let's say a really competent programmer actually finds an exploit and then holds a network and then holds the entire network ransom, we haven't really tested the security of a network. So I hopefully all the networks that have launched recently and then launching soon will eventually create enough value in them so they attract actual hackers.
Yeah. That's right.
Yeah. Sure. And Austin, last but not least.
So I guess in terms of what I'm optimistic about, I think, I've been around the DeFi space for about 3 years, and it has just been fascinating to watch. It started with, okay, so you've got these wallets, and then you've got DEXs, and then you've got lending and margin trading, and I've been fascinated to watch the evolution of the financial instruments that exist in the DeFi space, and there's going to be some bumps in the road without a doubt, but we're doing things that are in some ways catching up to the conventional financial systems, and some ways doing things that the traditional financial system never could have dreamed of doing. So, I'm just really eager to see where it keeps going.
Yeah, we're all buckled in. with that, thank you all for joining us today. This was really, really interesting. I think we literally touched a lot of infrastructure, whether it was layers 0, 0.51, smart contracts. For the listeners, if you have any questions, you know who to reach out to. And again, thank you for Draper Goren Holm for having us today.
Thanks, everyone.
Thank
thank
you.
you.